Howdy, it's Tubalcain again, and this is What Makes It Work, episode number 18, entitled How a Dial Indicator Works. And here's some examples of indicators, and dial indicators are precision measuring instruments, but actually they do not measure directly, but they're used for comparing dimensions or checking variations, often in the inspection department. And they need to be held firmly in some type of holder or fixture. They're not handheld generally, and they will amplify and measure these very small displacements. So let's take a look at some of the different kinds of instruments, and in general they can be divided into just several different kinds of indicators. For instance, there are what we call dial indicators, these right here, these three right here, and test indicators. In general, test indicators, such as the last word indicator, have a small range of just 20 or 30 thousandths, where dial indicators are half inch, quarter inch, or a full inch, some even longer than that. And test indicators won't do that. In general, we think of test indicators as being a little bit more precision, but I'm not really sure on that. It's kind of a blurry thing. But among dial indicators, there's two main types rather. The plunger, the back plunger type, and then the front plunger type like this, which is really probably the most common that you're going to run across in any shop. And I'm going to attempt to show how this type of indicator works. And you know, this is almost old technology now, because all of it can be done now with electronic indicators such as this that will measure both in English or metric, and really do not have all of the gears and other precision parts inside. Although I haven't had one of these open, but you know what it is to open up a television or something. You can't really see how it works, where these will be a little more self-evident when I open them up. Nick out of Ohio donated several indicators to me so that I could take them apart and show you, I hope, how they work. But notice that some indicators are reading in tenths of a thousandths, and it'll always tell you right there whether it's tenths or thousandths or metric. Now when you have indicators that have a long range like this, you're also going to have that other little dial that will count the number of revolutions, so you have to include that in the other reading as well. And they usually have a dial that can be loosened and rotated so you can zero it out, and sometimes these little indicators here, they can be moved around so that you can work within a certain range if you're testing something in an inspection department. Most indicators, well, I shouldn't say most, but indicators often have a lug on the back of them. But you're also going to see some that do not. For instance, here's the back of another indicator that this is actually the back here that was machined for a different purpose, to be held into a fixture. And well, you're just going to see all kinds of mountings, but probably the lug type is going to be the most prevalent. If you look through the Starett catalog, you're going to see pages and pages of indicators, and this is usually called the balance type, where we have a plus and a minus, and it just goes to 50. Actually, it's a full 100, but 50 down here, and it's plus in one direction and minus in the other. And some of them have the dial that is a full scale. I'm not sure what you call it here, but it's 100 thousandths all the way around. Notice that the plunger goes all the way through, and you're going to see that a long extension on indicators that have a long range. I'll show you one of those in a minute. You can buy indicators with different types of tips. Usually they're rounded like this. That's probably the standard kind that you're going to see, but here's a specialty tip, and you'll see pages and pages of them in the catalog too. And here's another tip that is somewhat rounded. here is that long indicator that I was talking about. That's a Mitutoyo, and it travels about 2 inches, but you can also see that it's long on the other side as well. Has a lug on the back. Alright, now let me take a couple apart, and I don't really want to destroy any of these indicators because of the possibility that I can't get them back together. So I'm using older indicators, or those donated indicators that don't really matter, but yet it kind of bothers me to take something apart where I don't really have the watchmaker's expertise, and they are as precision as a pocket watch inside, and some of them with jeweled movements. I believe I forgot to mention a few moments ago that test indicators also involve levers. There's probably a few gears in there, but they have levers or levers. But that's not what I'm going to talk about anyway. This little dial indicator here came in this case, and I imagine it's from Europe. Well, we know it's from Europe, and it's metric, and I'm thinking it's German or Swiss or something of that nature, a little velvet lined box, and I already took the bezel off. This is called the bezel, and it also has a lens or a crown. We used to call them a crown on a watch, but I don't really know. Okay, and on the back of this, well, I'll show you in a minute. Let me zoom in just a little bit. Again, metric, and you can see, and I've already had the hand off, and it's just kind of stuck on there, but I had to make a little puller to get it off. But all of these plunger type, as far as I know, are based on the rack and pinion principle. And looking on the back, it says October 1944, so if it was made in Germany and it's got a serial number on it, the war was waging and they were already getting short of materials, but it is aluminum and it's quite precision. So let me pull off that hand again, if I can, without destroying it. I've got a little pan there, and I'm working with tweezers and smaller jeweler screwdrivers and so on, and then this dial comes right off. That's aluminum. I've already taken those 2 tiny little screws out, and this all reminds me of the big clock factory that I went through in my hometown, West Clocks, where they made these tiny little gears and screws and all of that on these Swiss screw machines when I was a kid. Now you can buy a $2 electronic watch. This will come off like that, and then looking in the case, the machined aluminum case, you can see the plunger. And by the way, do not oil the insides of these any more than you would a watch. They need to be cleaned, but probably by somebody that knows what they're doing. But the rack on this one actually looks like a thread, and it's not a thread. This is the rack right here, but it's a round rack with the teeth all the way around, and a spring here, almost like a little hairspring, returning it to its 0 position. And there's literally a bearing here, actually a linear bearing, just a good fit, on each end to hold that in alignment, the plunger with the rack on it. Continuing with this little German indicator now in metric, I put the dial back on just so, and the hand, so you can see that moving. But looking at it from the back side, again. It is magnetic, so it actually is a tiny little cast iron casting, I believe, and it's been plated. At first I thought it was brass, and I'm really surprised that it is not brass. There might have been tremendous shortages in Europe when they made this. Let's examine this now the best I can, and this one's really simple compared to the other ones, and therein lies its beauty. And again, there's the pinion gear, which, by the way, appears to be very much worn. I'm not getting a good close-up on that at all, but it appears to be worn from heavy use building airplanes. So we've got the pinion there, and remember that the rack is over on this piece, and since the rack was round, they didn't have to worry about controlling the rotation of this like we did on the other one. So it does. Plus it's yeah, we don't have to worry about this rolling because of the way the rack is made. Looking at the little gears now, actually the gears are quadrants, which means it's 1/4 of a gear, because there wasn't room in the case for a full gear of that diameter, so it's probably a pretty brilliant design. Okay, to simplify things here, I've taken this quadrant that my finger is moving out of play, because that's the hysteresis or the backlash preventer, and looking at it from this side, you can see by moving this little gear that is connected to the pinion, and see the tiny pinion in the center, that shaft is what the needle is mounted on. So it's a very simple movement. And now I'm gonna, if I can, swing the other one back into place. So you can see both of those quadrants are acting on this tiny little pinion at the same time, and that's what's preventing lost motion or backlash. We absolutely cannot have backlash. We need to have the same reading. If it moves one graduation in one direction, it should move one graduation in the other with the same degree of accuracy. And that's what that little hairspring and extra gear is all about. So how's that for simple and yet brilliant German engineering or European engineering in a small package with very few parts? Now when I do the federal indicator in a few minutes, you're going to see that it has many more parts and is much more complicated. This one is relatively crude in that there is no jewels in the movements, that I can tell anyway. That's just like a plain little bearing. And a stamping, all one piece, onto a piece of cast iron, but they do have numbers on there. For whatever purpose, I don't know. So that's it on that little plunger type indicator. Did you find that interesting, I hope? Now, don't turn this off because I'm not done. Now let's take a look at this Starett indicator. And I'm not going to take this completely apart because this is a good indicator, but several things about this. And first of all, some indicators are going to have a shock absorbing device up here. I don't believe this one does. And a lot of these indicators are built in a similar manner, but they vary with the manufacturer and all of the patents they have. And if you want to see something interesting, if you like this, go to Google Patents, and look at some of the patent drawings and the description of the movements. But in this Starett indicator now, this is a metric one. It's jeweled. Can you read the word jeweled there? And there's the stock number. And this reads in, I put my glasses on, 0.005 millimeters, and it only has a range of 1 1/4 millimeters, very little range. You can see here on the plunger, not much range. And this is a balanced type because it has a 0 with a minus and a plus. So let me turn this over, and I've already taken the back off. And this is a plastic back. You can see where they're making things cheaper and cheaper. I don't believe that this is a real old one. Also, if you've worked in industry, you'll see that on precision instruments, well, there's some kind of control number there, but also it will tell when it was calibrated last. So there's a little date there. But looking at it on the back, again, a rack and pinion. And the pinion is a rather thick one, possibly used for different models, and there's a lot of teeth on the rack, more than you would need for this range, but I suppose that's also a part that would be used on different models, and Starett makes many, many models. And notice the little rod right here going into this brass slot, and that keeps the rack from rotating because it's a round rack. Also, notice here that this can be, oh, I'm turning the wrong thing here. This is what I want to turn. You can change the engagement of the rack and pinion, and that's why there's slotted holes here. Okay, that's probably irrelevant. Can you see the jewels? There's a jewel. Now remember, a jewel is just a precision bearing. They usually are artificial rubies, so I can see at least 3 ruby bearings. So this was an expensive one to make, even though they're cheating and making things cheaper and cheaper. And then as we get into the inner workings here, this piece is die cast. And there is a plastic gear. A little disappointed to see that in a Starett. Sorry, Leroy. I don't know what I expect. It probably doesn't matter. There's that hairspring, and again, the hairspring is to prevent hysteresis. Now, hysteresis, again, is the lag between the input and the output, so that in any indicator, when it moves in 1,000th, let's say, and back out 1,000th, those have to be exactly the same, the input and the output. So we need to prevent that hysteresis, if I'm using the word correctly. I always thought that was a word that applied to transformers in electricity. Hysteresis loss. I had a professor who used to talk about hysteresis and eddy currents. I didn't know what he was talking about because the man was brilliant. Now, if I take this apart, the whole thing's just going to fly apart, so I'm not going to do that. But again, there's a gear train in there. You see the different gears and different layers. There's actually 3 layers of gears that will give it the ratio that it needs to read and, you know, change the linear motion into rotary motion and into those graduations that you see there. All right, that's enough on the Starett. Let's look at a Federal. Federal is a major player in indicators. I remember seeing those as a kid, as a teenager. I think those are the first ones I ever saw was a Federal. But this one reads in thousandths, this in 10,000ths. This is a rather newish one in good condition. I really don't want to ruin it. This is the one I'm going to sacrifice. And you can see they look very similar. but there's a lot more gears in this one because it's the 10,000th. So you just can imagine that we need to do some different things inside here with the gears in order to measure tenths of a thousandths over just 1,000ths. This one's a little sticky. Now I'm going to take this bearing plate off of this federal indicator here, and I've already moved 3 screws, and of course the risk of this whole thing just flying apart when I do is so. Get my big hand out of there. I'm like a kid taking his dad's pocket watch apart, but I've got this little brass plate off, and then turning it upside down you can see the jeweled bearings there, the 3 red rubies. Now taking this out, I had to disconnect the hairspring from this little shaft right here, and now I lost the bearings. That is, I'm not able to actually move the mechanism anymore because these gears lack the support on the top side. But perhaps I can attempt to explain the gear train. Again, we got a rack here that moves in and out. Note the little spring on it to bring it into the home position. And the rack acts on this little pinion gear, which is moved away from it. And on the same shaft is a larger gear, and that transmits the motion to this next little pinion gear, which in turn is on the same shaft as this larger gear. And then underneath, let's see, and then this gear here is turning directly onto the tiny little gear that is on the shaft that controls the needle, but it's a very little gear. And then, as I understand it, the larger gear here, along with the hairspring, is what controls the hysteresis, that is the lag, that is the lost motion, or the backlash. So that is essentially how the mechanism works on a federal indicator, precision as it is. Now wish me luck in getting this little beauty back together. You will be hard pressed to find much information on indicators in books, but this is a book on measurement by IBM, and they have a cutaway, and this is nice because it shows the different layers of gears, the intermediate gears, and there's names for all of those, as you can see here along the outside, but I'm not always using the correct name. But this would also be another way to explain the gear train, and this looks fairly similar to what I just showed you. Where did I put that? I'm wondering if that isn't a federal. Yeah, do you see a lot of similarity there? This may be a federal, I'm not sure, but again, the mechanisms are very similar from manufacturer to manufacturer. So I hope this video was interesting to you, and you can see that what we're doing here is changing linear motion to rotary motion, dividing it into its correct denomination, I guess I'll say, so that it shows up on the dial in thousandths or parts of a millimeter or tenths of a thousandths or whatever is needed. And remember, it's not a direct reading measuring device. It's used mainly for comparing, but and in inspection. Hope you liked this video. This is tubalcain saying so long for now, and I'll see you in my next video.